Hello everyone, in this video I'm going to show you guys another example of sketching derivatives, graphs of derivatives. So in this case they have given us over here that this graph that you see here is the graph of your first derivative. They want us to draw the original function f of x and the second derivative graph. Okay, this is a pretty challenging exercise, so feel free to rewind whenever you're not certain with the stuff that I'm talking about. Okay, so if you look at the first derivative graph, you can see that there are two. Okay, first of all, we need to know that this the first derivative graph tells me the slope of my original function, correct? The first derivative is the slope of my original function. So, which means when x is equal to -2, when x is equal to 0, when x is equal to 2, my slope, the slope of my original function is equal to 0. Okay, so that's what I should have. When do you have, if you think about it, when do you have a slope of 0? It's either your maximum or your minimum points, correct? So when x equals to -2, 0, and 2, that's when you will find your relative maximum or minimum. So let me put down those points. So this is -2, this is 2, and so if you think about this, if I look at the graph of my f prime, this is positive and this is negative. So which means when this is positive, my original f of x is increasing, and this part is negative, which means my original f of x is decreasing. So increasing, so we're moving from increasing to decreasing. I have a maximum point here, so I'm going to put it somewhere here. Okay, so this is a maximum point. Alright, so now this is from x is equal to -2 until x is equal to 0. My graph is always negative, which means my graph is always decreasing. Alright, so maybe my graph looks something like this. This is just a brief sketch. Maybe my graph looks something like that. Maybe, not sure yet. Right? We don't know that for sure, but maybe the graph will look like that. Anyways, so now let's put down. So here I already have a maximum there. I'm gonna have, this is from negative to positive. So from negative, which means my f of x is decreasing, and passing 0, my f of x is increasing again. So maybe I should have then that means I will have a decreasing, increasing. I will have a minimum point somewhere here. I'm going to put it somewhere here. Now you might be wondering, why don't I put it here? I could, right? I could, as long as it is vertically aligned. So I could have the minimum point there, but here is, that doesn't make sense because this is a max, right? That's a maximum point, and this is a minimum point. How could a minimum point be at a higher value than my maximum point? Right, so that location right there doesn't make sense. I'm gonna put it maybe somewhere here. Okay, this is my minimum point, and then my graph is gonna increase until here. That's when I will have another maximum point because this is increasing, and then slope is 0, and then slope is negative again. So I'm going to have another maximum point somewhere here. Alright, so this is it for now. Right, that for max. This is also max. And this is my min. Okay, the thing is, I'm not going to connect the graphs yet, not yet, because I'm not so sure about my concavity. In order for me to draw the graphs, I need to know my concavity. Because, for example, over here, even though I know that this is increasing, this is all positive, which means my graph is always gonna increase, but my graph could increase this way, right? Or let me change a different color. Or my graph can increase this way. Oh, didn't change it. Or my graph could increase this way. Right, so I'm not so exactly sure what's my concavity. The yellow line gives me concave down, and then the pink line gives me concave up. So I don't have that information yet. Right, so I will need to look at my second derivative. Okay, so I'm going to make another sketch on this side, and that will be my second derivative graph. Alright, so let's do that. Again, feel free to rewind this video if you're not so sure with the parts that I'm talking about. Okay. Okay, so this is my, let me label this. This is y is equal to f of x, which is my original function. And here y is equal to f double prime of x. Okay, this is my x. This is my x as well. Alright, so even though I don't have, I don't know exactly what the shape of my f of x looks like, but it's okay, because in order for me to sketch my second derivative, I don't really need my f of x, right? I actually need the graph of my f prime x, which was given to us. Okay, so now before we do this, we actually have to think about what does f double prime, what information does it give us? So it gives us two things. Number one, concavity, right? But that's the concavity of my f of x, right? So that gives me the concavity of my f of x. Now the second thing is it gives me the slope. It tells me the slope of my f prime x. It gives me the slope of my f prime x. This over here is exactly the same as, sorry about that line. Okay. That is exactly the same concept as what does the first derivative tell us? The first derivative tells us the slope of my f of x, right? So the second derivative graph will tell us the slope of my first derivative. Okay? Alright, so let's try to do that. Alright, so let's look at our first derivative, our graph of the first derivative. Alright. So we're looking at the slope of my f prime. So over here, the slope is pretty special, and over here, the slope is pretty special too. Why do I say that those 2 points have special slopes? Because at those 2 points, the slopes are 0. Right? So which means when x is equal to -1, this is -1, this is -2. When we are making sketch of derivatives, we need to make sure that things are vertically aligned. Okay, it is very important that they are vertically aligned. So your sketches should have your x-axis labeled properly. Alright, so I'm going to have a point there that's 0, and here I'm having a 0 again. So my sketches are going to be a bit ugly because I'm using a mouse. I'm pretty sure you guys can do a better job than I can. Right? Okay, so let's look at this. Before this minimum point, before this relative minimum, my graph always have a negative, right? It is always decreasing. So which means I'm just simply gonna put anywhere that represent that it has a negative slope. That point could be there, the point could be there, could be here. In fact, it can be anywhere, but we just have to make sure that it is at the negative part. Okay, I'm gonna put a point there. Now, after x is -1, after this relative minimum, everything is increasing. In fact, it is increasing until the maximum point. So after this -1, everything is increasing, and then until the relative maximum, which happens at x is equal to 1. Oop, I put that. Okay, so I just need to make sure that I have somewhere between them, there's a maximum. Right? So there's a maximum point right here. If you don't like that, I can put it here. I can put it there if I want to. It doesn't really matter. But what matters is, you must make sure that it is increasing. Okay, and then after the relative maximum, everything is decreasing again. Okay? So the slope is going to be negative. So it seems like my Alright, let me try to draw this with the mouse. Seems like my f of second derivative looks like that. Looks like an upside down parabola. As you can see, I'm trying to connect all of them. Oh man, this is taking me forever. Okay. Oh, what did I do? Alright, there you go. Voila. That is the graph of our second derivative. Okay? Now, my second derivative is done. And I can sort of use this second derivative graph to help me to sketch my f of x, which was sort of incomplete because I wasn't sure what the concavity is. Okay? So I need to look at the signs. So now I'm looking at this point, the concavity. So if I sort of make a very ugly sun diagram, -1, and this is my 1. Everything here is negative. Everything before x is -1 is negative. Between -1 and 1 is positive. After 1 is always negative. So which means before x is -1, my f of x, which is the graph here, is going to concave down. And since, so which means maybe I should put that down here, -1. Right? So everything here is going to concave down. But even though I have no idea what my y coordinate is going to be when x is going to be 1, I'm just simply going to put a point there. But what I do know is this is going to increase, go up, and then concave down. And then after -1, in fact from -1 to 1, you can see that it's a positive, which means it's going to concave up. So things are going to concave up now until 1. I have no idea where the 1 is going to be. Oh, let me draw that. Go down, down, up, 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 and then I'll say maybe it's over there, right? So I'm gonna assume that there's a point there, and then this is after 1, everything is concave down. So concave down, passing to the maximum, concave down again. Okay, so that's it. This is my graph of f of x. Now, I hope you guys see that I was pretty flexible with where I put down some points here, right? Why did I put a point there? That point could be anywhere, in fact. You could have the point all the way up here, you could have the point all the way down there. But what's important is you must make sure that everything before x is -1, everything is concave down. We don't really know exactly what is the y coordinate of this point, so we can sort of have the freedom to make it up, and you guys should try to take advantage of that so that this curve is as smooth as possible. Same thing for this point. So passing through this point, which was random sort of, I went over the relative minimum, and then I need to make sure that this goes back up, right? So over here, if you look at this second derivative sign diagram, I know that everything passing 1 should be negative, which means concave down. So I'm just to help me make this curve smoother, I just simply put a point there. This point could be all the way up here if I want to, or all the way down there if I want to. But just to sort of make this more symmetrical, personal preference, and you guys should take advantage of that. Okay,